Good morning, students. Let's start with the chapter 8, Study of Compounds, Hydrogen Chloride. Under that chapter, we have to study the hydrogen chloride in its gaseous form and in liquid form or in acid form. Hydrogen chloride with the molecular formula HCl, H for the hydrogen, Cl for the chlorine. Molecular mass is 36.5. We can find it by adding the hydrogen and chlorine atomic mass. By this, the 36.5 it is coming. The bond between them is the covalent bond. It can be made by the sharing of two electrons. When the sharing of two electrons between the hydrogen and chlorine is being done, then the single hydrogen, covalent bond is forming, and this is shown by the Lewis structure or the dot diagram. It can also be shown with the orbital structure in which the two orbits being shared up, in which the two electrons are being shared, and that sharing leads to the covalent bonding. For the occurrence of the hydrogen chloride gas, it occurs in the volcanic emission, and it is also present in the gastric juice of the mammal. The percentage in the mammals is the 0.2 to 0.4%, and it helps in the digestion. Under the topic of the preparation of the hydrogen chloride gas, the first preparation is by synthesis or direct combination. By synthesis or the direct combination, first of all, we have to treat with the hydrogen gas with the chlorine gas. The condition is that we have to maintain the here sunlight. It should be diffuse sunlight. If we are not providing the diffuse sunlight, then the process will not occur. There will not be forming of the hydrogen chloride gas. If we are providing the diffuse sunlight, then only the hydrogen chloride gas is forming. It means that if we are giving the direct sunlight, then it is very explosive in nature. On the other hand, if we are giving this reaction under the dark, then it is negligible. To assess that negligibility or to increase that negligibility, we are using activated carbon. That activated carbon is using to increase the reactivity of the hydrogen, and after the reaction, the hydrogen chloride gas is forming. Another way is the burning jet of the hydrogen. This burning jet of the hydrogen also burn in the chlorine, leading to the hydrogen chloride. On the third way is on igniting mixture. We are igniting a mixture of the hydrogen and the chlorine gas. By burning ribbon of the your magnesium, HCl is also forming by this one. The second process, that is treating metal chloride with the concentrated sulfuric acid. By treating the metal chloride with the sulfuric acid, there will be a formation of the hydrogen chloride. We can check it through the reaction. Sodium chloride treating with the sulfuric acid, the temperature we have to maintain it. First of all, if we are taking the below 200 degrees Celsius, then the sodium bisulfate is forming with the hydrogen chloride gas. And if we are taking the above 200 degrees Celsius, the sodium sulfate is forming with the HCl gases. The laboratory preparation of the hydrogen chloride gas. This topic is very, very important. For that, the reactant are the sodium chloride and concentrated sulfuric acid. For that, we have to set up the apparatus. Under this apparatus, that apparatus is being set in the laboratory. Check the spotlight. First of all, this one is your round bottom flask. This is your washer tank, and this one is your jar. Here, the U-tube is present. That is a delivery tube. This one is also a delivery tube. This one is called a thistle funnel. Now, what happened during this process? First of all, we are taking the sodium chloride in a round bottom flask, and the heating is going on simultaneously. The use of this one, round bottom flask, is to maintain the heating process. Means this round bottom flask can be used under that condition where the heat is high, means the temperature is very high. Thistle funnel is being used so that the concentrated sulfuric acid being added drop by drop inside that one. Always remember your sulfuric acid should be added drop by drop, and this thistle funnel should be entered in that solution. As that process begin, the reaction start, the effervescence begin, and that effervescence leading to the formation of a gas. This gas being transferred to another washer tank by this delivery tube. Here the presence of the concentrated sulfuric acid is there, which will dry up that gas, and this gas again being transferred to the jar where it can be collected by the upward displacement of air because it is heavier than air, and the 1.28 time it is heavier than air. For the reaction, what the reaction is being done, sodium chloride treating with the concentrated sulfuric acid, temperature we have to maintain the less than 200 degrees Celsius. Sodium bisulfate is forming and HCl gas is forming. Though it is a reversible reaction, yet after the completion as the hydrogen chloride, it is continuously escape as a gas. That's why it is happening. The reaction, if we are taking that reaction above 200 degrees Celsius, then in place of the bisulfate, there is a formation of the sodium sulfate with the HCl gas. Here we are using the sodium chloride as a reactant. The reason behind it is that it is cheap and it is preferred for the preparation of the hydrogen chloride. Next one, in place of the sulfuric acid, we can't use the concentrated nitric acid. The reason behind is that it is volatile in nature. And if it is volatile in nature, it will volatile or it may volatile along with the hydrogen chloride. This gas, which is being formed here, after the reaction, after the effervescence, has to be purified. For the purification, we are using the concentrated sulfuric acid. Now, so many for the purification, other drying agents we can use it, like the phosphorus pentoxide and quicklime, that is calcium oxide. But we are not using, the reason behind, because they are both are reactive in nature with the hydrogen chloride, and if they are giving the reaction with that one, then we can't get the hydrogen chloride. See that your phosphorus pentoxide reacting with HCl, there is a formation of the phosphorus oxychloride with a high your HPO3. On the other hand, when we are taking the calcium oxide treating with the hydrochloric acid, calcium chloride and water is forming. But in case of the concentrated sulfuric acid, it is non-reactive in nature. That's why we are using a drying agent here. Under the topic of the collection, hydrogen chloride gas is collected by the downward delivery by the upward displacement of the air. The reason, because it is heavier than air. How much time heavier? 1.28 times heavier. It can't be collected over the water. The reason behind is that it is highly soluble in water. Due to the highly solubility nature, it cannot be collected over the water. Now, next one is the identification. How you can identify that it is your hydrogen chloride gas is there, HCl gas is there, because when the jar is filled with that gas, the fumes appear on the jar mouth. And when these fumes are being appeared, we will treat it with this ammonium hydroxide. When we are treating you with the ammonium hydroxide or the rod dipped in the ammonium hydroxide being coming near the mouth of that HCl gas, there will be a formation of ammonium chloride of the white fumes. Dense white fumes of ammonium chloride will produce, and that will identify it is a hydrogen chloride gas. But for whole process, some precaution is also there. The lower end of the thistle funnel must be dipped in the concentrated sulfuric acid. We have to add up the thistle funnel to the concentrated sulfuric acid so that no gap should be there. Delivery tube should be dipped in the drying agent, that is the concentrated sulfuric acid. The temperature we have to maintain it nearly 200 degrees Celsius. We can't exceed the temperature above the 200 degrees Celsius. Reason, because the apparatus is made up of the glass which may crack, or fuel is being wasted, and if the sodium sulfate is forming, it is a hard crust will stick to the glass and it is difficult to remove. That's why these conditions we have to maintain it to get the hydrogen chloride gas, and the process can be done smoothly. Means the temperature we have to maintain nearly 200 degrees Celsius. We have to not uh, go beyond the 200 degrees Celsius. Now coming to the next topic, that is the physical property of the hydrogen chloride gas. Color, that is colorless gas is there. Smell with a pungent choking smell, very very important point, kindly note it down, underline it. Pungent choking smell is there. Taste, it is sour acidic in taste. Physiological nature, very important concept, it is corrosive in nature. It irritate nose, throat and your lungs is there. Next one, density. As it is heavier than air, then it is about 1.5 time heavier than air is there. Boiling point minus 83 degrees Celsius, melting point minus 113 degrees Celsius. Liquefaction and solidification, as the pressure is being increased about that 40 atmosphere and the lower temperature is maintained, then it will liquefy. Solubility, it is highly soluble in your polar and non-polar compound. Polar means your, because of the presence of the covalent bond, it is soluble in organic non-polar solvents such as acetone and toluene also. Next one is how to prove that the HCl gas is heavier than air, as we have done in the physical property. For that one, we have to again set up that apparatus. We can take first of all a jar with a burning candle, and in that jar we can pour the HCl gas. The jar full of the HCl gas is being poured in that your jar. What will happen? Your candle will extinguish. What is the reason behind it? The reason is that HCl gas being heavier will be coming or settling in that jar. The air will go out, and by this one, no contact with air will be there. Your candle will extinguish. Now, the next one experiment to show that the HCl gas is highly soluble. How to prove that it is highly soluble in nature? Highly solubility can be proved by the fountain experiment. This fountain experiment is based on the diffusion or the difference in your what pressure is there. For that one, first of all, we have to set up the apparatus. Again, the inverted dry round bottom flask we have to set up like this one jet is being inserted, another one, this one is your dropper. That dropper is being filled with the 1 or 2 drops of the water. In that round bottom flask, your dry HCl gas is present, and the whole apparatus is being set up, and the cork is being arranged, and that apparatus is being set up like this one. In that container, the blue litmus solution is present. What will happen? How this system will work? First of all, we have to press this dropper. By pressing this dropper, as this dropper has the 1 or 2 drop of the water is there, when we are pressing it, that water will go inside this round bottom flask, which contain the dry HCl. As HCl is highly soluble in water, the solubility in water will be there. The HCl gas will dissolve in that water, and by this, inside this round bottom flask, the pressure decrease. There will be a lowering of the pressure, and if here the lowering of the pressure at the bottom, the pressure will increase, and from that one, what will happen? This blue litmus solution will go upward from the higher concentration to lower concentration. At the end, when the jet is there, this your blue litmus will come out. As the HCl gas is present, it will turn to red, means the blue litmus will showing the red splash, red fountain, splashing of the red, your fountain will be there. This shows that it is acidic in nature and highly soluble in water is there. Now, one thing, keep in your mind this line, that is the principle. The outside pressure being higher pushes the blue litmus solution inside through the jet tube. The blue litmus solution turned red due to the acidic nature of hydrogen chloride. These are the very, very important point. Kindly note it down, make it underline. Due to the highly solubility of your HCl gas, the fumes in the moisture forming tiny droplet of the hydrogen chloride. These two activities are very, very important. Coming to the chemical properties of the hydrogen chloride gas. First of all, the combustibility. As we have done, the gas is neither combustible nor supporter of combustion. It doesn't burn, rather it extinguishes your burning spread. We have done this experiment above also. Thermal dissociation. It will dissociate if we are treating the HCl, and the temperature is above the 500 degrees Celsius, then it will dissociate into the hydrogen gas and chlorine gas. With the metals, but that metals which are above the hydrogen in the electrochemical CZ. When we are treating these metals with the hydrogen chloride gas, then the metal chloride will be forming with the hydrogen gas. Hydrogen gas lead to the pop sound and burns with the blue flame is there. Always remember, whenever the metal treats with the hydrogen chloride, but that metal should be above the hydrogen in the electrochemical series, it will form the metal chloride with the hydrogen gas. After that, treatment with the ammonia. It reacts with ammonia gas, and with the reaction of the ammonia gas, it will lead to the white solid, that is ammonium chloride. With that, your question is very much important, and the question is coming like this: name the gas which is formed, or name the gas which is formed when one solid is being what dissociate, or when name the solid when the two gases combine to form a gas. When two gases combine, then the ammonium chloride is being formed. That's all for today. Kindly revise it thoroughly and make the notes of that one. Go through the all activities and your preparation. Laboratory preparation is very much important. Fountain experiment is very much important. Highly solubility process is very much important. And laboratory preparation, very, very important is there. Thank you. Have a nice day.